So we just had two extremely destructive earthquakes strike Venezuela, one a magnitude 7.2, the other a magnitude 7.5. Interestingly, less than 30 minutes later, a magnitude 7.2 also struck Japan off the coast. Thankfully, minor damage reported from that, no lives lost. But a lot of people are now asking, what's happening? Is this normal? Can we expect more earthquakes to occur in the future and maybe close to where I live? And what can I do to prepare, if anything? So to answer these questions, let's first learn a little bit more about this earthquake that struck Venezuela, and then talk about the overall state of the Earth energetically in terms of earthquakes, volcanic activity, and more. And then also we'll go through some basic survival preparedness actions that anyone can take, especially those that live in earthquake-prone areas, Japan being a very clear example of that. It's the most seismically active place on the planet. So Venezuela was a rare event, though there is a history of these sort of earthquake doublets striking Venezuela. What happened was there was a magnitude 7.2 earthquake that struck about 20 kilometers down on a major plate boundary. This is where the plates are grinding past each other in a strike-slip fashion. And in fact, the motion is that South America is going to move west and the Caribbean plate is going to move to the east. And that's exactly what happened. But in addition to that magnitude 7.2, about 40 seconds later, a magnitude 7.5 earthquake struck and even closer to the surface, about 10 kilometers down. So these are shallow quakes and they're very powerful at magnitude 7 plus, meaning it's very destructive. And the close sequence of those quakes in time means that their seismic waveforms, the energy that they release, combine together constructively into even larger ground motion. So you have these giant waves propagating across the surface, and that caused buildings to collapse and many lives to be lost and many people to be injured. There's 40,000 plus people missing as a result of these earthquakes in Venezuela. It was incredibly destructive. Now, we had something like that happen back in 1812, almost identical. So these plate boundaries and in general faults, they accommodate movement between distinct blocks within Earth's crust, which is the outermost surface of the Earth. It's solid and fairly cooled and condensed, and what happens is as plate tectonics continues and the plates are moving around, you get this stress to build up and strain accumulates until eventually it ruptures. So in 1812, there was also a earthquake doublet that struck Venezuela along this fault at similar magnitudes that caused similar destruction, though back then you didn't have these high-rise buildings, for example. But there were 10 to 30,000 lives lost as a result of the earthquakes in Venezuela in 1812. Notably, you also had big activity in the United States in 1811 and 1812 on either side of the earthquakes in Venezuela. You had tons of magnitude 7 and 6 earthquakes strike the New Madrid Fault. This is under the Mississippi River in America's heartland. And then you also, after the quake in Venezuela, you had an earthquake doublet strike Southern California, both of them being magnitude 7.0 and greater. It was a 7.5 followed by a 7.1. What you can do to prepare for an earthquake is you want to make sure that you have a disaster plan in place. If you are at work, you want to know where you need to go to get safe. If you're at home, same thing. So the moment you start to feel shaking and or you get an alert that an earthquake is coming in, you want to get outside, away from tall buildings, objects, and trees, if that's possible. If not, you want to take shelter under, let's say, a strong table, or if you don't even have that option, under a door frame. You want to cover your head, use your back to protect your front, curl up, and these are some basic things you can do during the earthquake. They have these apps that can give advance warning for big earthquakes. It depends on your distance from the epicenter where the earthquake actually ruptures. But because there are 3 types of seismic energy released from an earthquake, you have P waves, S waves, and surface waves. That compressional P wave is the fastest. It's also the weakest. So it just does a little jolt, but it's enough for people to get a heads up as to, okay, an earthquake is coming. These cell phones or different devices record these P waves, send out an alert, and that can give you 5, 10, 15 seconds, which is enough time, if you act quickly, to grab a loved one, maybe grab a pet, or just to get yourself out of a dangerous location. For example, these high-rise buildings in Venezuela that were built to subpar construction standards and earthquake seismic standards. You also want to make sure you have some food and water available, like survival rations effectively. Maybe put it all in a bag. It's called a bug out bag. So something you can grab by the door, have like some slip-on shoes always ready by the door. So you can just quickly put your feet in the slip-ons and run out. A hand crank radio is going to be a good idea. And they even sell these folding solar panels now that can be attached to a little battery, and maybe you have a cooking element there. So now you can have a little bit of something to charge your phone, something to charge maybe the radio, or again, it could be a hand crank radio, a light, and then even something to help boil water, cook food. These are all good things to have. Maybe an emergency blanket, a jacket, some basic stuff like this. First aid kit, this is what you want to have on hand. Now, Venezuela basically is a sign of what can occur. And this was an extremely destructive earthquake, but we see that these happen every now and then. I mean, it happened also back in 2023 in Turkey, very similar. It was a magnitude 7.8 followed up by a magnitude 7.5 on a major strike slip boundary. What you have to consider with these big earthquakes is how the energy propagates out across the entire globe. It doesn't just dissipate in the immediate area, though a lot of the energy does. You actually have the surface waves propagating out across the entire globe and circumnavigating the globe multiple times. And what's been shown, and there's more research coming out every year highlighting and detailing this phenomena, is that that seismic energy can load into faults and increase the stress and the strain on them and take them closer to their critical stress threshold. So there's history in 1967 when there was an earthquake in Venezuela. 4 months before, there was an earthquake in Colombia, same magnitude, 6.7. So Colombia right now, I think, is not looking too great, at least as it relates to a forecast of future activity. Doesn't mean it's going to occur, but it's definitely possible that we get a follow-up earthquake in Colombia. Maybe not as destructive, but it's possible. Also, you can look to the Caribbean, you can look to Central America, you can look to Mexico and the United States, because there is this history with the United States and its two main seismic risk zones, which is the New Madrid seismic zone and the Reelfoot Rift underneath the Mississippi, and also the San Andreas in California, because you had these seismic bursts occurring in those locations centered around the 1812 earthquake in Venezuela. That was in March. So maybe there's a connection between how the South American plate moves relative to the Caribbean plate that then impinges upon the overall plate boundary between the Pacific and North America. And as a result, now that you have new stress dynamics building, it can cause the San Andreas, for example, in California, to finally rupture. That's certainly possible. We don't have a super long time frame of that. We don't have 5,000 years of data showing that that happens over and over. We have our one example from 1812, and we have recurrence intervals for these faults, but we can't precisely say that they've ruptured multiple times in sequence. But there's increasing research and data coming out showing that faults can synchronize and rupture simultaneously. So it's certainly a possibility, which people need to be mindful of. So now that we've had this big earthquake in Venezuela, 150 kilometers of fault rupture, but there's some odd things happening nearby as well. You had this huge amount of uplift that occurred along a beach in Trinidad and Tobago. That's unexplained, but clearly it's like 25 feet of the beach uplifted related to this. There's other dynamics. What they showed with the Great Tohoku earthquake in 2011 was that about a little less than 20 minutes after the magnitude 9.1, you had this seismic wave reflect off the outer core and reach Japan again. This was a shear wave. So it's a shearing motion, went down to the outer core, traveling through thousands of kilometers of mantle, came back up about 16 minutes later and caused Japan actually to move 6 millimeters to the east in the direction of that thrust earthquake. So these seismic waves, it's not just the initial earthquake that can then cause a rupture. You can get these refractions and reflections if it's a powerful enough earthquake to perhaps interact with other faults and cause them to rupture too. That's what the data is starting to indicate. Some other research that's being done now is on the effect of external actors, you could say, on the Earth. Because you have plate tectonics. Earth is very alive energetically compared to, for example, Mars or the moon. But we know that Mars and the moon also get earthquakes. But Earth is a very active geophysical system with plate tectonics. So you get this stress and strain to accumulate, and they reach critical stress thresholds, and then you get a rupture. Well, you can get triggers upon faults and plate boundaries that cause them to rupture once they're at a critical state. One trigger is the moon and the sun through tidal forces. We do see that strong tides are able to cause faults to rupture. It's not the biggest effect. At a global basis, it's like a 0.5% increase during fortnightly tidal maximums, think the new moon and the full moon, but we also do see a clustering of the strongest earthquakes around new moons and full moons. Not every time, but we often do see that. So we know that the tidal forces have a big impact, especially when they're the strongest, king tides. And that happens when the moon is at its closest to Earth, and the strongest king tides will be when not only is the moon closest to Earth, you also have the Earth closest to the sun, which occurs in January. The Earth will be furthest away from the sun in its orbit in July. So these sort of king tides, which we had just about 10 days before these earthquakes in Venezuela, can also load a ton of energy on the faults and cause there to be a rupture by acting as a trigger mechanism. They have an effect that's small but significant, and it's not just ocean tides. People think of tides as being just the ocean coming in and going out. It's also, you have earth tides. So the earth itself, the crust itself, is displacing and warping in this vertical way, and that can create fractures, and therefore if you have more fracturing along a fault system, that can cause it to finally rupture because it's reducing that critical threshold needed for a rupture. In addition to that, you also have the sun. This is something that's being researched into more and more. As we get more data, you just need simply more years of data to really be able to say conclusively what's happening. But we see that there are certain types of space weather that correlate really well with big earthquakes, namely these large coronal holes on the sun that emit these high-speed streams of solar wind. When those interact with Earth, we often get these big earthquakes to trigger, and that's exactly what happened in Venezuela. So right as the high-speed stream connected to Earth, and there's a magnetic component to that too, so the solar wind actually magnetically connects to Earth's magnetic field, and the solar wind velocity went up to 600 kilometers per second. The moment that happened, those earthquakes popped off in Venezuela and Japan. So there's this connection as well that's being explored into by many, many people, and we won't really know the exact mechanisms until we get more data, but we've only been getting these sort of observations of the sun where we can see coronal holes and getting good measurements of the solar wind for about 50 years now. And as it relates to the tidal influences on earthquakes, well, the lunar cycle has about a 20-year period. It's actually 18.6 years. Until we get 3 or 4 or 5 of those, basically 100 years of good seismic data matched up with lunar records, we're not going to be able to fully understand the tidal influence on the Earth as it relates to earthquakes. But we do have initial data that's very suggestive that these are powerful external forcing agents that act as triggers. So this lines up perfectly with what we've been seeing, because in this solar cycle 25, the sun undergoes a flip in its magnetic field about every 11 years. There's some variation, but about every 11 years. You get periods of high activity, lots of solar flares, these explosions on the sun, lots of solar storms are launched out towards us, causing the aurora and geomagnetic storms. And then you also get periods of quiet activity, solar minimum. We are right now at the end of solar maximum, the beginning of the descending phase for solar cycle 25, and solar cycle 25 has in general been a weaker solar cycle as compared to solar cycles 22, 23, and even some prior than that. 24 was quite weak, and we had a ton of activity centered around the anomalously weak solar cycle 24. The 2011 Great Tohoku earthquake being a good example. It occurred during that weak solar maximum. Well, we also last year had the magnitude 8.8 megaquake that struck Kamchatka, just to the north of Japan, making 2025 one of the strongest years ever for earthquake activity. We've actually in Japan been seeing a huge burst of seismic activity to the north. There's been multiple magnitude 7s, magnitude 6s, tons of magnitude 5s, 4s, everything else. They're close together in magnitude. So the question is that all foreshock preliminary activity before something bigger occurs? Or is that relieving strain on these faults? It's hard to say. If the faults only have a stress buildup to magnitude 8, let's say, then that's probably what's happening. The stress is being relieved. But if we go back to 2011 with the Great Tohoku earthquake, you had a magnitude 7.3 foreshock that occurred 2 days before the 9.1. That 7.3 energetically is a drop in the bucket compared to the magnitude 9.1. So if there's another high magnitude 8 or magnitude 9 earthquake in the future, the near future for Japan, in these locations that are having all the earthquakes right now, this is northern Japan, east coast, off to the east, well, then it's really maybe more of a sign of something big coming rather than relieving stress on the fault. It is fundamentally reducing some of that stress and strain, but it's also spreading, again, that seismic energy out to nearby faults and blocks within the subduction zone there. So it really depends on what the actual stress threshold is. And there are sections of the subduction zone with Japan that didn't fully rupture with the Great Tohoku earthquake, that were loaded with a lot of energy from that, and now have also been loaded with energy from the magnitude 8.8 megaquake for Kamchatka, July 2025, that are probably pretty close to their critical stress. And so as we go down through the descending phase of solar cycle 25 and into solar minimum, then we're probably going to be seeing more big earthquake activity. And if it strikes in a location like what happened in Venezuela near big population centers, it can be extremely destructive, especially if we get doublets, which we do see every now and then. Or like what happened in New Madrid under the Mississippi in 1812, you had multiple magnitude 7s and 6s strike over the span of about 6 months. So imagine that happening nowadays with all the infrastructure development and the many millions of people that are living there. One other thing to note is that we do see this correlation, or rather anti-correlation, between solar activity and volcanism on the planet. As solar activity goes down, we see volcanism go up. And we've been seeing pretty exceptional volcanic activity during this recent time frame. We had one of the strongest volcanic eruptions in record history back in 2022 with the Hunga Ha'apai eruption. That was January 15th. And we're seeing big volcanic activity around the globe in 2025, right now in 2026, and we're going into that solar minimum. In fact, we just had a magnitude 5.7, I believe, earthquake strike under Mount Fuji, about 50 kilometers down, but directly underneath that big stratovolcano. And, well, if you look at the history, Mount Fuji last erupted in 1707, and it was triggered by a big earthquake. So there's this connection between earthquakes and volcanic activity as well. Those seismic waves propagating through the magma chambers and the conduits and the plumbing system for the volcano disturbs the volcano and can cause it to erupt and even explode violently. So as you get these powerful earthquakes to occur around the globe and their seismic energy radiates out across the entire globe, you're having energy now loaded into all the other faults that exist and plate boundaries that exist across the globe, because energy is neither created nor destroyed. So as that energy is released, it's absorbed somewhere else. And so these other faults, which maybe were just slowly building up strain, now get a quick boost upwards in strain. The stress really goes up, and now they're that much closer to rupturing. And that can cause other faults to then rupture, and creating this whole kind of chain reaction cycle that eventually will die down, but we don't know when. But the main areas to be really worried about, I would say right now, would be Japan, because of all these earthquakes that we've been having in Japan, indicative perhaps of something bigger coming. Also, California, the stress along the San Andreas Fault is at some of the highest levels we've ever seen based off of historic earthquake data and modeling that they're doing of the strain rates and the accumulation. Also, I would think New Madrid is potentially in the crosshairs because of that connection in time between Venezuela and New Madrid. Same with Southern California. Colombia also being so close to Venezuela and having some pretty big faults there could have some significant activity, mid-magnitude 6, perhaps even magnitude 7. And there are other locations as well. We have New Zealand that its alpine fault has a reoccurrence interval of about 300 years. Its last big earthquake was 1717. So it's ready to go. We just don't know when. So the key thing to keep in mind is that there's nothing that we can do to stop earthquakes. But if we live in an earthquake prone zone, we need to be prepared. So get some basic supplies. Have what we call a bug out bag. So you can just grab it and go. And make sure you have that earthquake alert on your phone. So if something does happen, you have 5-10 seconds to prepare, hopefully a little bit longer, and that can save your life and perhaps save the lives of other people as well.